Okay, so what about if we have 4 terms? If we have 4 terms and we want to factor, we can actually factor by grouping. This also works with 6 terms or 8 terms. So to factor by grouping, we group them into 2 groups. And typically you're going to group the first 2 terms together and the last 2. You can switch the order and make as long as there's a GCF, you can do the grouping differently. So our first group is going to be 4xy plus 8y. And our second group is going to be 3x plus 6. And then what we're going to do is find the greatest common factor for each group. So for this group, the greatest common factor would be 4y. And if we factor out 4 divided by 4 is 1, x divided by nothing is x, and y divided by y cancels. 8 divided by 4 is 2, the y would cancel. And over here, our GCF is 3. 3x divided by 3 is x, and 6 divided by 3 is 2. And there is a 1 here you can see. So I always call this a smile method because when we look at this, if these 2 terms are the same, then you smile because you know you're doing this correctly. If these do not come out the same, you need to backtrack and figure out where your mistake is. Okay? Now we look and we say what is common between the new terms, which are here and here. And what we'll notice is that part that is the same is the common factor, which is 1x plus 2. And if we factor the 1x plus 2 out of the first term, what's left behind is the 4y. If we factor the x plus 2 out of the second term, what's left behind is the plus 3. Okay? And I kind of just did the 2 steps in the same order, but the GCF is here, and the new factor is here, and that is our answer. So if we distribute this back out, we'd get back to the original 4 terms we had here. Again, if we take out our GCFs, what's left behind is your second factor. Okay? And then ask, do you think grouping matters? Again, can you do this in a different order? You can. We could regroup this as 4xy plus 3x plus 8y plus 6. Okay, and we're going to do the same process. The GCF over here is x. If we factor out an x, we get 4y plus 3. The GCF over here is 2. If we factor out a 2, we get 4y plus 3. And then our common factor is 4y plus 3. And what's left behind is x plus 2. Notice this is the same thing we got here. So the order, you can shift the order around and still get the same results. Okay? So let's do the same idea with this problem. Group the first 2, group the last 2. The GCF of the first 2 is 2m. If we factor that out, we get k minus 6. The group GCF of the second term is 7. If we factor that out, we get 6 minus k. And then we look and we say, oh no, we can't smile because these are not the same. However, they are very similar. The only difference is the sign. So if we think about that, how can we change this to make them the same? Let's keep the first one as it is, and let's factor out a negative 7 instead. When we do that, that makes the k positive and the 6 negative. And now we have k minus 6 times 2m minus 7. And we have our greatest common factor and our factored term. Okay. So that's how you factor by grouping. So you're going to find the GCF of the first 2 terms and the GCF of the second 2 terms. We're going to look for that common factor, and we smile when we get there. That becomes our first factor, and then what's left behind becomes our second.